Yeah, today the webinar will be on performance boosters. So we're going to look at how to get the most out of your machine. Not everyone's machine is the same, so we're going to look at some of the minimal requirements, the maximum requirements of your hardware, but then also look at what you can do within Civil 3D to make the Civil run better. So we're going to talk about hardware requirements, your RAM, your processor, your operating system, graphics card, hard drive. This is actually a screen cap of what my current computer specs are. My laptop is 3 years old, so I am running an i7 3610 processor, 2.3 gigahertz. I do have 16 gigs of RAM. I am running Windows 7 64-bit. And I obviously do not have any pen or touch input devices on my machine. So RAM. With Civil 3D, 8 gigs I would recommend that being the minimum for Civil. Autodesk website, I think, actually has it down to 4. They may have upgraded it recently. But 8 gigs, definitely if you're just doing small sites, if you're a surveyor, if you're not doing much design, but 8 gigs. 16 gigs if you use Civil 3D on an everyday basis. You're dealing with 2-3 acre sites, you're dealing with corridors, you're looking at quantities. If you're doing what Civil 3D was designed for, if you're using that on a daily basis, I would definitely recommend 16 gigs. If you're going above and beyond, you're going into QTO, you're going into large 50-acre site developments, you're dealing with 28-mile roads, you're dealing with pipe networks that for an entire city, going 24 gigs, definitely not going to hurt. If you use the GIS portion of Civil 3D on the planning and analysis tools, and you're bringing in large shape files, definitely I would recommend going to 24. I have 16 again, and I use GIS, and every now and then, depending on what shape files I bring in, it will be sluggish. Before I had 8 gigs and it would crash if I brought in all the line work for the 7 metro county area of the Twin Cities. So 8 gigs I would recommend as a bare minimum, 16 if you're a good user, 24 if you're doing really complex projects or lots of designing inside one single project. Your processor. Here at CTC, we'd recommend an i7 3rd generation, or I guess greater, or newer, depending on how you want to word it. 2.5 gigahertz for the speed. Mine's a 2.3, so mine is a little slower. We'd recommend a 3 gigahertz processor for any of the everyday users. If you're just dabbling, the 2.5. And then 4 cores. Most people know that there are 4 cores, 6 cores. There's even an 8-core processor out there right now. 4-core processor would be probably where we'd want to start. That's pretty common nowadays. I don't think any new machines come out with a dual core anymore. Most of them are quad cores. Just for the fact that you can have multiple softwares running, you can have Outlook, you can have Civil open, you can have Pandora running if you like your music playing while you work. And having those multiple cores, some of that software will be pulled from one core, Civil 3D will pull it from another core. But 4 core is good. 6 if you want. Right now I think 8-core processor would be overkill unless you're doing a lot of rendering with your software. Civil 3D is not the best software to render in, so I'd recommend the 4 for the minimum, maybe a 6. And Intel does have an i7 4790 with a 4 gigahertz speed, and it's pretty reasonably priced. It's not bad, it's pretty good. I mean, obviously the 4 gigahertz is above and beyond what we'd recommend. And you want to build your computer now to meet the requirements from 3 years, because as we know, we're not building a new machine or getting a new machine every year. So that's why my computer's 3 years old, and it right now is just under the specs. So we did pretty good at speccing that out 3 years ago. Operating system, pretty simple. Windows 7 64-bit is supported on all the softwares that are current. So 2015, and then even going back to 3 versions, so 14, 13, and 12. If you do buy a new machine right now, typically it is going to come with Windows 8. I'm not sure if you can still buy a new machine and request Windows 7 and have it replaced, or have Windows 8 replaced. But Windows 8 is supported, but it is only supported back to 2014. So if I buy a new machine right now and it comes with Windows 8, but I'm still running Civil 3D 2013, technically it's not supported anymore. So look at what software, what version you're still running for what version of Windows you want. If you're running anything older than 2014, definitely try to get the old version of Windows 7 and not Windows 8. And as most of you know, you can run Civil 3D on a Mac, but you have to have it running in parallels, so it still needs a Windows environment. They have not made a Civil 3D for a Mac environment yet, so everything still needs to run in a Windows 7, Windows 8 environment. Graphics card. Everyday user, 3 gig plus for the public power users. If you're just dabbling in it, if you're doing a lot of plan view stuff, nothing too intensive, you could probably get away with a 2 gig, but we definitely recommend a 3 gig graphics card right now. Again, if you're doing anything with the GIS portion, highly recommended that the minimum is 3 gigs and possibly even go up to a 4 gig. And as I put on here, NVIDIA does have a 4 gig graphics card out there right now, and it is still relatively cheap. Hard drive. Basically, solid state hard drive versus mechanical hard drive. Definitely, you're going to see a vast improvement with a solid state hard drive because it has no moving parts. It's basically a giant flash drive. My machine has a 750 gig solid state hard drive. It works great for me. My software loads relatively quick. My computer will boot up in less than 30 seconds. Maybe you don't need a 750 gig hard drive, solid state, but I would at least recommend a 250 gig minimum and have that be your C drive. And then, because your drawings, they're being stored on the network. So if you're storing all your files and documents on a network drive, then the 250 gig hard drive solid state's going to suit your needs, because you only need it for the software to be installed on. And I think right now I'm running, I think 150 gigs worth of software installed on my machine. So having a 250 hard drive right now gives you that extra 100 gig, because as you know, Windows likes at about 20 gigs of free hard drive space on your machine for copying temporary files, moving it back and forth. So try to always keep your machine only at the max 80% full to have things run smoothly. So hard drives, minimum 250 gig hard drive just to run the software on your C drive to have it installed. And then if you have to, if you still store things locally, then get a mechanical hard drive. We call them spinners, and get one, a 500 gig hard drive there for your files. Those are definitely cheaper than the solid states. They serve their purposes, but again, the solid state is going to be a lot faster, and you will see vast improvements. So that was the basic hardware configurations. You can call into us, you can email us. We can try to give you recommendations. You can send us your, hey, I'm looking at a computer, here's the specs, what do you think? We got a couple guys here that know processors, graphics cards like the back of their hand. They'd be more than happy to help you out with any possible suggestions that you may have or questions that you may have that they can offer suggestions to. So hard drive, our hardware for your machine, we just covered that. Now let's talk about what you can do for performances within Civil itself. Civil works when you have small files. So more drawings, the better. Autodesk recommends that you have one drawing for each feature that you're doing. So they actually recommend it's better to have 5 1 meg files than to have 1 5 meg files. We recommend that your civil drawings, you try to keep them under 5 megs. You can go up to 10 megs if you're looking at a large corridor project. Obviously, breaking up corridors into smaller regions, it has its limitations. But more drawings, the better. It's better to have your survey, your topo, existing conditions in one drawing, and then have your alignments and profiles in another drawing, then have your corridors in another drawing, have your plan and profile sheets in another drawing, and so on. And that's what we talk about here. Model drawings. Have one drawing specifically for the survey or the base. Have one drawing specifically for utilities. Have one drawing for gradings if you're doing site grading. Removals, storm and wastewater plans, electrical, erosion controls. Have separate drawings for there. Use the dereference, so data shortcuts, and X-referencing. File size will decrease drastically. I have a little screen cap here, and I have a base drawing. It was an IMX import of a surface in Bloomington, and just that IMX import, the file size is 33 megs. I did a data shortcut of that exact same surface, and in a new drawing, it's just under 900K. I mean, 3% the file size. I have another data shortcut one with the surface looking a little bit different, and we'll get into that, but even there, I saw a difference. And then I have it X-referenced in instead of data shortcutted, and it's slightly larger, but still 915K versus 33 megs. It's a no-brainer. Use your data shortcuts, use your X-referencing. I don't want to start an alignment and a profile drawing in a drawing that has this 33 meg surface in there. It's just going to make my drawing slower, and it's going to bog things down. When you're dealing with surfaces, and I bring in a surface, that surface that was 33 megs, it was an IMX file. It came in from InfraWorks, or maybe it's coming in from LiDAR data or laser scan. Crop your surface down. Crop it down to the area that you need. This little area right here that I have in the image, it's a 4 mile by 4 mile surface. Well, if I'm only dealing with something in a 1 acre site, crop that surface down to that size. It's going to decrease your file size. Level of detail. For any of you that don't know level of detail, what it does is it will only display certain contours depending on what level you're zoomed in at. So right now, I may only be seeing the 10-foot contours for minor and the 50-foot contour for the majors for this 4 by 4 mile area. But if I zoom into my 1 acre site, now because I'm in a much smaller area, and when I regen, I'm only regenning that area, it will show me every 1 foot, 5 foot contours. So depending on how big of the area I'm at will determine how much of the contours it will actually show. If I turn the level of detail off, it will show every 1 foot contour or whatever display setting I have it set at. That right there, it's not going to change your file size, per se, but it's going to change your performance. It's going to tax your processor much, much less. So now things will go smoother. It'll be a little bit faster, but you're not going to deal with a slower regen rate. Next thing with surfaces, use a DEM surface instead of a tin surface. It actually will use your resources, your processor, 1/6 of the memory of a tin file. You do have the capabilities of exporting out your tin file as a DEM model and then re-importing that file in as a DEM. And it's going to take up, again, 1/6 of the memory. Less resource intensive. Your processor is going to run faster, things are going to regen, things are going to save much, much quicker. And then surface simplification. It basically eliminates unnecessary points. So if I have a cluster of points, and I might have 100 points in there, and they're all measuring 100 feet for an elevation, it will actually eliminate the majority of those points because they're they're unneeded. They're irrelevant because I can get rid of them and my tin's still going to look the same. It's not going to modify anything. So as we know, 3 million point surface is going to take longer to regenerate than a 2,000 point surface. Even if it's the same surface area, that 2,000 points is going to work much faster because the tins, the triangles on your tin are a little bit larger and it has less things to think about to reprocess. So surfaces, you got the 4 things. Crop to the size that you need. Play with the level of detail. Leave it on. Use DEM models or surfaces instead of tin surfaces if you have large surfaces. And then use the simplification. Get rid of unnecessary points. Other things that you can do in Civil 3D, deal with corridors. Use multiple corridors. Some people will go out and say 5 miles per max on a corridor. Good rule of thumb, if it's a complex corridor, if you're just using a simple lane, curb, daylight assembly, yeah, 5 miles works great. If you're dealing with a corridor that has targeting both horizontally and vertically, and you're dealing with islands, complex intersections in those corridors, you may want to keep it down to about 2 miles. Create separate corridors. It's going to speed things up. And then on top of that, you got that 2 mile complex corridor. Try not to have one region for that whole corridor. I know there's conditional subassemblies out there that says, hey, if this exists or if this statement's true, do this, and if it's false, do that. I know you could get by with having one region for an entire 5 mile corridor with conditional subassemblies. You know, yeah, it works, but now you have one region and it's always going to reprocess. Every time I pan the drawing, it's going to regen. Every time I move, regen, it's going to process that entire region. Breaking that corridor up into 5 separate regions is going to help speed things up if you turn off those regions. Hey, I'm not working in that region. Go ahead and turn off, I'm working at the intersection. Turn off the regions that are half mile away. I'm not working in that area. I don't need to see them. Just turn them off. And your drawing is going to not only decrease in size, but it will also speed up when it comes to the processing. Third thing is frequency lines. If I'm not looking to get quantities out of it, set my frequency to 50 feet. Is my tin surface going to be completely accurate? No. It's going to be a little choppy, but my processing is going to be much quicker. 5 feet. set it down to 5 feet, set it down to 1 foot when you're ready to do quantities. We've done tests setting a 3-mile corridor up with 50-foot frequency lines, doing a regen, and then doing the same regen when the frequency lines are at 5 feet, 6 times quicker at 50 foot. Well, yeah, it took 43 seconds instead of 2 minutes to regen it. Hey, that's not that bad. It's only a minute. But when you have to do it over and over and over and over again, that time adds up. And then eventually, those nickel and dimes, if you want to talk about money, will add up to $100, give or take. If you're not doing quantities at that time, set your frequency lines much higher. Another thing that you can do to save time or help speed up things is you can literally create a tin surface for specific regions. So I might have a region on the first 2,000 feet and then another region for the next 2,000 feet. Create a tin surface just for that one region, turn it off, set it to a no display. When you're not in that region, it's going to speed up your processor. When you're ready to take that corridor surface on for pipe networks, create one overall surface, paste it in, create your data shortcut, and then bring that surface in as a data shortcut. As we saw in the beginning, I had a 33 meg surface, data shortcutted in, it was just under 900K. Do the same thing with your corridor surfaces. Create the surfaces, data shortcutted in, you're going to bring in less data. And started mentioning this thing before, turn things off. Some of this stuff will help file size, some of it will help processor time. Set your surfaces to no display if you're not needing them. It will tax your processor less. It will decrease your file size. Bigger the site, the more it's going to save. Corridors, I mentioned it on the last slide. Turn your regions off. Again, it will tax the processor less, and it is going to decrease your file size. I'm going to show you a corridor here that went from 17 megs with the regions on down to 1.7 megs with the regions on. Finally, templates. Build your templates to be lightweight. Create multiple templates. Have a surveying template. Have a design template. Have a plan production template. You may even have 2 to 3 design or plan production templates. And in doing so, you're going to have styles that are specific to the task. Do I want to have an alignment style in my surveying template? No. Do I want to have a pipe network style in my surveying template? No, not unless I'm part of my surveyor's job is to actually create a network of existing pipe networks. Only have the styles that that template is going to be responsible for. What that's going to do is it's going to start your template out much, much smaller. The out-of-the-box template for Civil 3D has 415 layers, I think. It has all the alignment styles, it has all the surface styles, it has pipe network styles, it has grading styles. If you're not going to use those, get rid of them. Start out with a smaller template. You start small, you're going to end small. If you start big, you're only going to go bigger. So it's definitely create multiple templates, have the styles in your templates specific to that template that you're using. Don't have styles in there that are just taking up space, making your template larger in size just because. In your templates, you have code set styles. Showing what you need. Do I need to show all those frequency lines in my corridor? No. No, I don't. It's visual for me in the design stage. I could technically turn them off. Do I want to show the boundary of where it daylights? Maybe. Play with your code set styles. Have your civil objects, your cross sections, your corridor, your assemblies, have those only show what's required for your project. Turn off things that aren't necessary. The more you turn off, the faster your job is going to process. And that goes down to hatching. Obviously, hatching, it's big in processing. If you have an ANSI 131 hatch, it's going to take a while to process because it's a lot of lines. Only hatch when you absolutely have to. And then once you've hatched, turn the hatch off when you're not ready, if you're not using it at that time. Layout or paper space, our rule of thumb is 5 layout sheets per drawing. Maybe less if it's a complex model. Maybe you want to drop down to 3 or 4. If it's something really simple, like again, a simple corridor, going up to 10 or so might be decent. Got a couple questions right now, looks like. Scott, do you want to talk about those?
All right, Scott, we got 2 here. The first one is when you export a DEM from a tin, do you lose any data? And can you import it back as a tin and expect the original surface?
You will lose a little bit of quality converting a tin to a DEM. And because you will lose a little bit of data, if I converted the DEM back into a tin, no, it would not be the original. So you will lose a little bit of quality, but depending on what you're dealing with, maybe that DEM model will suffice and will give you the quality that still is necessary for your model.
Okay, and then what's your definition in megabytes of a lightweight template versus a heavyweight?
My definition of a lightweight template, you're looking at maybe 700K, 500K for a lightweight template. Starting with a heavyweight, starting with something that's over a meg already, to me is excessive. You would definitely want to have it a little bit smaller, because if I'm starting with 1.5 megs, then you're going to end up always being bigger. And having a 1 meg drawing is where you want to be, 2 megs. So if you're already starting at 1.5, there's no place to go but up. So 700K would be a good size for your template. So we'll go ahead and we'll jump back into things. So again, layout space, 5 layout sheets per drawing. If it's only layout pages, you don't have anything in model view, you could probably get a little bit more. Definitely utilize the sheet set manager, helps keep all your layout sheets organized. Oops. So what I'm going to do is I'm going to do some demos or examples of what I'm talking about here. So I'm going to jump into Civil 3D, and I have my base drawing, which when I click on it, you will see that it is the tin surface AIM existing ground. And I got a dereference surface, and as you look, it is data shortcutted. You can tell by our little icon there of that AM existing surface or existing ground. And then I have my X reference surface, and when I click on it, you see up here in the top on the ribbon, it is an external reference. So I have the same surface in 3 models. And when I open up my Windows Explorer, here is the base, which now it's actually down to just over or just under 32 megs. Here is my X reference 1, which is at 915K. And here is my dereferenced at 895K. So just by using a data shortcut or an X reference, I've reduced my file size down drastically. And I'll quickly come in and I will save that drawing. And I can see that it was saved at 1231 and it's 897K. You won't see much of a change on this site, but just by changing my properties in a data shortcut to no display, say apply, say okay, save the drawing again, 896, it dropped 1K. Where you're going to see that major benefit, surface properties, no display, apply, okay, save, surface, F5. Oh, it's saved. That didn't even drop down that much. Larger surfaces where your tin lines are tighter, where you put a smoothing surface in there and then turn it off, that's where you're going to see much more of a performance. I apologize, I failed to put in that smoothing. But you will see a change by putting a no display if you do a lot of edits or modifications to that surface. Since this surface was just brought right in, I didn't see much of a change, except for when it came to the data shortcut. The next thing I wanted to talk about was corridor regions. I actually have an alignment here. It zigzags to fit inside that 4x4 mile, and this zigzag corridor is actually just under 17 miles long. For the sake of speed, I went in and I modified just this little portion of the regions. I had the exact same drawing copied, and it is the same area, but what I'm going to do is I'm going to go into my corridor properties, and I'm going to turn off the regions except for the intersection. So if I look at model space, or not model space, Windows Explorer, I see corridor 17.7 megs and corridor region 17.7 megs, both saved earlier this morning. Minimize that. So there's corridor region. And now I'm going to go into my corridor properties, and I'm going to turn off two of those regions, just two of those regions. I'm going to leave my intersection turned on, say apply, rebuild, say okay. Now my area is just the intersection. I'm going to save my drawing, come back into Windows Explorer, and that corridor region is now 1.7 megs. Almost 10%, or only just around 10% of the size of the original. Turn your regions off if you're not using them. If they're not necessary for what you're working with, turn it off. It's going to be easier for me to regen a 1.7 meg file than it is for me to regen a 17 meg file. And on top of that, I'm going to jump back a little bit while I'm in Windows Explorer here. I have another drawing, and it was called Alignment and Profile. And that was an XREF, or it had the data shortcut of my surface in there. And as we can see, the data shortcutted surface in there was around 900K. I went in and created those alignments and profiles. And you're talking a 17-mile corridor in one, and the other one was, I think, 3 miles. I created a surface profile and I created a proposed profile, and that drawing right there was only, 1.2 megs completed. And then when I derefed, I created a new drawing and data shortcutted in the surface, the alignments, and the profiles, it started out as only 900K. So basically what it's saying is the alignment and profiles, both existing and proposed, went from 896 to 926. It was basically 30K worth of information for that alignment and profile. Again, another reason to use data shortcuts or X-referencing. So with my base drawing for my corridor being at 920K, when it was done with the regions turned off being 1.7 megs or 1700K, I'm only looking at 800K worth of information for that 17-mile corridor because I didn't need it because it was turned off. I'll quickly open the alignment and profile deref, and that's all there is in there. And then here is the alignment and profile drawing. So here is my 17-mile corridor, and then I'll zoom in and see if I can do the math really quick. Station 161, so 16,000 feet. We're looking at, like I said, just over 3 miles. And this file right here, as a data shortcut, only accounted for 30K worth of information for that profile, and then actually drawing in the alignments. So turn things off when you don't need them. Set your frequency lines to a higher frequency when you're not worrying about quantities. And then, again, turn things off. Set it to no display. Turn regions off. Possibly convert to a DEM model versus a tin surface. Take a couple questions right now, if we have any. Scott, do I have any more questions?
Yeah, Scott, someone was wondering, how does the corridor hatching affect performance in plan view, section view?
Yeah, most definitely. The corridor hatching, the performance, it depends on your drawing scale. Obviously, if I'm drawing at 200 scale, my lines are going to be a lot wider apart than if I'm down at 30-40 scale. If I'm dealing with a site, if I were to hatch that 4 mile by 4 mile, it's going to kill my processor. If I'm only hatching 100 feet by 100 feet, I'm probably going to be fine. So it's definitely, I mean, it's going to kill your performance with the processor based on what scale your drawing set at, and then again the overall size of the hatching. Plan view, section view, again, it's going to be based off of, am I drawing at 40 scale or 100 scale when it comes to the section view or the profile view. You can hatch things up. Civil 3D has a lot of features that you can have hatching available, and then all you have to do is have it turned off when it's not necessary. Right before you go to plot, turn it on. Any other questions?
Yeah, it looks like we got one more here. If there's any other questions, please feel free to send those in, and we'll take a look at the upcoming events. But what does a data clip boundary do to a surface, and how is that different than an outer boundary?
The data clip, it will, it's very similar to an outer boundary. Honestly, I don't have a good, a data clip is better than an outer boundary because of this. I don't have a good answer on what's the difference. I typically just use outer, or I will use the data shortcut. But the data clip, basically, it does this, very similar to what the outer boundary does. Is you just set up the perimeter and it modifies it. The difference is it stores it in a different location, and then if that surface that was clipped changes, you have to actually go in and manually update that surface inside the data clip. Whereas if you use the outer boundary, it automatically updates right away. So it's a couple more steps than the outer boundary, but it's going to reduce the file size a little bit more than the outer boundary does. If that doesn't answer your question per se, feel free to send us an email and we can talk about it a little bit more.